Alright, so we're going to be talking about continuity. So you might have heard about continuity before. And the previous definition that you heard is that you can draw a line without picking up your pencil, which is great. I mean, that's still kind of what we're going to be using as our definition. But our new definition means that we have to have these three things. So first off, we want the limit to exist, which means as we approach from one side, we're going to be approaching the same point as we approach from the right side. So the limit has to exist. The second thing is that we want our function to be defined. So we don't want just an empty hole here. We actually want a point. The third thing is that for this to be continuous, we want that point to actually match up with my limit. Okay? So what we're going to be doing is we're going to be looking at this graph and deciding where is it continuous or where is it discontinuous, that's easier, and which of these following conditions have been violated. So if we look here, straight out the gate, let's go ahead and highlight where our function fails to be continuous. So if I'm drawing this graph, I can see that I'd have to pick up my pencil, draw this dot, and then keep going. So it's going to be discontinuous at -2. If I continue to follow this graph, I'm going to have to stop here and jump down here. So it's going to be discontinuous at -1. And as I continue on, well, we're also going to have this discontinuity at 2 because I jump and I'd also have to jump back down here. Great. So here's how we would, here's how we would write that answer. And also this is kind of how WebAssign is going to want you to write your answer as well. So we are going to have discontinuities when x equals -2 and when x equals -1 and when x equals 2. So when we're looking at these, let's check these out. So at x equals -2, the first thing is let's check out the limit. So the limit as x approaches -2 of our function equals 1. So we know that from the previous video. Now the second one is that we need to have our function defined. So we do have a solid dot at -2. So that means that if I plug -2 into my function, I'm going to get 1/2 or 0.5 out. So the third thing I need is that I need this limit to be equal to my function definition. So if you see here, the limit equals 1, the function equals 0.5. So since 1 does not equal 0.5, this is going to be the spot where we see failure. All right, now if we look at -1, well, what we can see is that the limit as x approaches -1 of our function is actually not defined, so the limit does not exist. Remember, for a limit to exist, as we approach from the left-hand side, I should approach the same y value as if I approach from the right-hand side. Now, since those are the same, the limit does not exist. We'll just keep going on these. The second condition is that my function has to be defined at -1. Since I do have a hole, or not a hole, a filled-in circle at -1, that's fine. 3 is going to fail because my limit doesn't exist, so of course it can't equal my function definition. Here is a little, well, like in the know fact, is if you fail condition 1 or 2, you will automatically fail condition 3. Alright, and for the second one, let's see, which condition is that one going to fail? Right, that's going to fail condition 1. So as the limit x approaches 2 for a function, that limit doesn't exist because they have the lines approaching 2 different numbers. So as I approach from the left-hand side, it's going to approach 2. As I approach from the right-hand side, it's going to approach 3. Also, if I plug 2 into my function, what I actually get out, this filled in circles, I'm actually going to get out negative 1. So, like I said, if you fail condition 1 or 2, you'll automatically fail condition 3. So D and E does not equal negative 1. So again, we fail on 1 and 3. 1 and 3. Okay, an example of where you would fail on 2 is if you just had an open circle. So for example, we would have failed here if this one didn't exist. Now for example 2, let's say instead of getting a graph, we get a equation. So where is this function discontinuous and what condition is violated? So if you remember from your previous math courses, what you need to look at when you're looking at a function is you have to look at making sure you don't divide by 0. So f of x is not defined when x equals 4. Therefore, it is discontinuous at x equals 4. Now, what we want to know is we want to know what conditions have been violated. So, first, let's see if the limit as x approaches this funny number actually exists. So remember, when we're evaluating a limit, the first thing we want to do is plug that limit in. So that would be 4 squared minus 4 minus 12 divided by 4 minus 4. Now, if we get 0 over 0, that does not necessarily mean that the limit doesn't exist. It means that we need to factor, cancel, and reevaluate. So let's see. That top part will factor into x minus 4 and x plus 3 over x minus 4, which these guys are going to cancel. The x minus 4 is on the top and bottom. So this limit is actually going to equal 7. So the limit does exist. Second is my function defined. So if I actually plug 4 in, do I get anything out? Well, no, because I'm dividing by 0, which means that my function is undefined. Alright, which means we break 3 because the limit does not equal our function value. So what this looks like graphically, in case you're wondering, is that as we get closer to x equals 4, and let's say we have 7 up here, what this graph is going to look like is it's going to look like a straight line, but it's going to have a hole in it. So because it has this hole, what's going to happen is that we're going to have to skip over it. So when I'm drawing this with my pencil, I'm going to be drawing, I have to stop, pick it up, and then continue on. That is why this is not a continuous function.